And at heart of the Rocky Mountains, shielded beneath 2,000 feet of solid rock, lies one of the most secure, most resilient military installations ever constructed by the United States, the Cheyenne Mountain Complex. Built in the early years of the Cold War, during a time when nuclear weapons were reshaping the nature of global security, Cheyenne Mountain was designed to survive the unthinkable, a direct nuclear strike, and continue operating even in the aftermath of total war. This mission, aerospace defense, early missile warning, nuclear detection, and the coordination of continental airspace security has made Cheyenne Mountain a cornerstone of North American defense architecture for more than half a century. The origins of the complex begin in the 1950s, when the rapid development of intercontinental ballistic missiles made traditional military bases vulnerable. The United States needed more than radar stations. It needed a hardened command facility deep underground that could not be disabled by the first wave of a nuclear attack. Construction began in 1961, literally by carving a cathedral-like chamber inside a mountain. The facility was completed in 1966, a marvel of engineering, sealed behind massive blast doors weighing 25 tons each. These doors are designed to absorb and disperse shock waves from a nuclear blast and can close in seconds if necessary. Every part of the structure within the mountain is mounted on deep, flexible springs, designed to isolate the internal installations from violent external forces, including seismic shock from explosions. Even if the ground outside is upheaved by a detonation, the command center within the mountain would remain stable. Unlike other military bases, Cheyenne Mountain is not visible from above as a traditional installation. Entering requires passing through long, reinforced tunnels, which separate the outside world from the interior. Once inside, the heart of the complex exists as a cluster of 15 buildings, constructed from steel and reinforced concrete, each sitting on massive shock-absorbing springs. These independent structures can move as much as a full foot in any direction without damage. The entire installation is connected by corridors, communication rooms, and command stations, all internally redundant so that a single breach or malfunction would not compromise the facility's function. The core mission housed here for decades was NORAD, the North American Aerospace Defense Command, a joint U.S.-Canadian command responsible for monitoring the skies of North America for hostile activity. During the Cold War, controllers here maintained real-time tracking of thousands of aircraft across the hemisphere, watching for possible Soviet incursions or missile launches. NORAD's radar, satellite, and computer networks allowed operators to model threat trajectories, identify airborne anomalies, and provide early warning alerts directly to the Pentagon and the President. In the most tense moments of the Cold War, when the United States was within minutes of nuclear confrontation, Cheyenne Mountain served as the nerve center of defense intelligence. The Russians knew this, and the Soviets factored the complex into their strategic planning, fully aware that Cheyenne Mountain represented one of the most difficult military installations on Earth to destroy. Cheyenne Mountain also includes fully independent life support capacity designed for long-term isolation. The complex can be sealed off with its own power generation via internal generators, multiple water reservoirs, and advanced air filtration systems that can remove radioactive particles, chemical agents, and biological contaminants. The facility's HVAC is not a simple ventilation system, but a layered defense mechanism capable of supplying clean air even in a post-nuclear environment. There are stockpiles of provisions, emergency medical facilities, fuel storage, and protected communication hubs built to function even in a global communications collapse. Technologically, Cheyenne Mountain was decades ahead of its time. The computing equipment installed evolved over the decades from early mainframe computers to advanced integrated systems. As technology accelerated, so did the capabilities of the command network. Incoming data streams expanded from radar signals to satellite imaging, infrared detection, missile tracking, and even near-space surveillance. When new threats emerged, from long-range cruise missiles to high-altitude ballistic vehicles, Cheyenne Mountain expanded its monitoring capability. Even now, it still houses systems for monitoring seismic events, missile launches, and nuclear detonations anywhere in the world. In many ways, it was the original real-time global intelligence fusion center. As national defense evolved, so did the roles of the facility. In 2006, the primary command operations of NORAD were transferred to Peterson Air Force Base in Colorado Springs, but Cheyenne Mountain remains a fully operational backup facility, capable of resuming full command control at any time. It is maintained in a continuous state of readiness. During times of heightened international tension or elevated threat levels, personnel and operations are shifted back into the mountain, ensuring that the core of America's command infrastructure remains protected. The bunker is not a relic, it is a strategic reserve asset. Infrastructure remains live, systems remain updated, and staffing remains flexible to accommodate rapid activation. Cheyenne Mountain, however, is not alone. During the Cold War and beyond, the United States designed a network of hardened command installations to ensure the continuity of government and defense command in the event of catastrophic attack. One of these is the Raven Rock Mountain Complex in Pennsylvania, sometimes referred to unofficially as the Underground Pentagon. Like Cheyenne Mountain, Raven Rock is built inside a mountain and contains hardened communication systems, blast doors, and subterranean operational spaces. It is designed to host senior Department of Defense leadership during wartime, and its role complements rather than duplicates Cheyenne Mountain's mission. Another crucial site is the Mount Weather Emergency Operations Center in Virginia. Primarily focused on civil government continuity, Mount Weather is where top civilian officials, including congressional leadership, would be relocated during a severe national emergency. Where Cheyenne Mountain monitors the aerospace domain and Raven Rock manages military command continuity, Mount Weather ensures that civilian governance and national leadership can continue to function. Further west, in Nevada, lies the Nevada National Security Site, formerly the Nevada Test Site, home to extensive underground tunnels and nuclear testing chambers. While not a command center in the same sense, its subterranean laboratories and hardened test bunkers represent another layer of strategic infrastructure designed for resilience and operational survival. In modern times, strategic nuclear command and control has largely evolved around U.S. Strategic Command at Offutt Air Force Base in Nebraska. An advanced, modernized installation, STRATCOM now oversees America's nuclear forces, space command elements, and part of its cyber defense structure. While STRATCOM is above ground, it is heavily fortified and supported by redundant digital and physical communication lines, and in extreme scenarios, Cheyenne Mountain could serve as a secondary node for command continuity. All of these sites, including Cheyenne Mountain, were created because of a single hard truth. In the event of a nuclear war, traditional command facilities would cease to exist almost immediately. These facilities were designed so that no single attack, no single missile, no single blast could blind or decapitate American command capability. They were built with the assumption that the first strike might eliminate Washington, New York, San Diego, or military hubs like Norfolk or Colorado Springs, but that deep underground, behind steel, rock, and shock-absorbing engineering, the heart of decision-making could survive. Inside Cheyenne Mountain today, much of the modern activity revolves around cybersecurity, missile detection, space surveillance, and electromagnetic monitoring. NORAD still uses the facility for operations during elevated threat levels, joint exercises, and fail-safe readiness. Personnel rotate through training, system testing, and operational drills to ensure that activation capability remains intact. While some systems have been relocated to newer command centers, Cheyenne Mountain remains the ultimate fallback, the control node of last resort, if everything above it fails. The encryption and communications technology here remains among the most secure in the world, with multi-level authentication protocols, hardened fiber connections, and isolated internal networks capable of operating independent of national infrastructure. The complex even incorporates emergency analog systems, secure radio lines, and manual control redundancies, ensuring that even in a cyber or EMP attack, command can continue. What makes Cheyenne Mountain unique is not simply its ability to withstand a nuclear blast, but its ability to continue functioning afterwards. not as a symbolic bunker, but as a full command center. If outside cities were silent, Cheyenne Mountain would still speak. If national grids failed, it would still power itself. If communication satellites were disabled, it would still receive classified terrestrial signals. If outside air were toxic, the air inside would remain clean. And if the world above were on fire, the world inside the mountain would still operate. In a time when military threats have diversified, from intercontinental missiles to cyber warfare, and from hypersonic glide vehicles to space-based surveillance, Cheyenne Mountain remains relevant because it is resilient. Military technology changes rapidly, but vulnerability to attack remains constant. The concept of survivability, physical, operational, and communication survivability, is still essential. That is why Cheyenne Mountain remains staffed, supplied, monitored, and maintained. And although much of America's modern command infrastructure has moved into advanced surface facilities, it is telling that the United States continues to preserve and invest in this fortress beneath the mountain. It serves as both symbol and safeguard, symbol of continuity, safeguard of capability. It exists as proof that even in a worst-case scenario, strategic command and aerospace defense would not simply vanish. Cheyenne Mountain stands today not as an artifact of 20th century fear, but as a quietly active, quietly vigilant bastion of national defense. Its walls of rock and steel, its springs and shock mounts, its sealed corridors and fortified doors. They are reminders that sometimes the most advanced defense is not the newest or flashiest, but the one designed